All right, we are back for lesson 5.6, and we are headed back to our mystery compound that we found on the table, and we have to figure out what it is. Um, and if you'll remember in the last lesson, we figured out the empirical formula. I'm going to write it up here. It was C2H5, all right? But we still don't know what this is, right? Remember, this is just the empirical formula. It could be C2H5, but it might be C4H10 or C8H20. There are many different options, but there's a way to calculate what it actually is based on the empirical formula. Okay? So, scientists can determine the molecular formula. Remember, that's exactly what it is. If we have the molar mass of the compound and the empirical formula. So if we know those two things, we can figure out exactly what it is. So here's the equation for that. The empirical formula mass times the molar mass, times N, equals the molar mass. So what we are looking for is N, which is the ratio here, to turn this empirical formula into a molecular formula. Remember when we did glucose, C6H12O6, that was the molecular formula. Apologize for the abbreviation there. When we converted it to the empirical formula, we had CH2O. So in this case, I don't have a whole lot of room here, but N would equal 6 because it's the number I divided by to get from the molecular formula to the empirical formula. Right? It is that ratio number. So we are trying to find this ratio number if we know the empirical formula mass and the molar mass, so we can convert from one to the other. Right. So like you see here, the empirical formula, I should have just written that up here, was CH2O, for example, my glucose, multiplied by the subscripts by N when N equals 6, and what you get is C to use to go along with that, H, N, Y, Z, O, oxygen, and Z. So for my example, when N equals 6, then we get C, 6 times 1 is 6. H, 6 times 2 is 12. O for oxygen, 6 times 1 is 6. So we convert that empirical formula to the molecular formula. Now let's do that for our mystery compound. Remember, we had C2H5, and we need to figure out what the molecular formula is. So we know that the mystery compound has a molar mass of 58.12 grams. So the first thing we need to do is divide the molar mass by the empirical formula mass. So the molar mass we just got told was 58.12 divided by empirical formula mass. I got to calculate that. It comes from the periodic table. I have 2 carbons. I have 5 hydrogens, which means 2 times 12, 5 times 1, 24, 5, add them together, I get 29. All right, y'all, this might seem weird, but I had to pause my recording to go help out Miss Wooten for, it's been about an hour now. And I don't really 100% remember what I was saying. So I'm going to start where I think I was, but I apologize if I repeat or have backtracked a bit. So we found the empirical formula mass from the periodic table. 2 carbons, 5 hydrogens, added that all together. And we are going to divide the molar mass, which was given to us in the problem, 58.12, we're going to divide that by the empirical formula mass, which is 29. So when we do that, we get 2. This number here, remember, is our n. So it is the number that we multiply by all of the subscripts in our empirical formula. Just like it says here, multiply each subscript in the empirical formula by n to get the molecular formula. N is 2. So my empirical formula, remember, is C2H5. So empirical formula, C2H5. We multiply those things by 2. 2 times 2 is 4. C4. 5 times 2 is 10. H10. And there we have the molecular formula. C4H10, which, if you care, is butane, which is what is found in cigarette lighters. Okay, so divide the molar mass you're given in the problem by the empirical formula mass, which comes from the periodic table. It'll give you a multiplier, and then you just multiply the subscripts times that, and you have your molecular formula.